Thank you very much for attending the session this morning. Essentially, I'm going to talk about the trend technology, deep security, which is our cloud-based flagship product for servers, and how it's going to work with, or how we integrate it with the AWS cloud using some novel functions. So, first of all, though, I guess I wanted to set the scene a bit and tell you a bit about what we've been seeing, the way things work. So in terms of the developing and computer evolution and the way things are moving. So obviously physical to virtual and cloud and containers and serverless are coming. And all of that's, as you go to the cloud, your traditional infrastructure ways of doing things change because you have this auto-scalable, very easy deployment type environment where you can just run things up with APIs. So we built deep security around those principles. One of those was, for instance, from SecOps to DevSecOps, is that deep security from trend is completely API driven. So your compute environment at AWS might be completely API driven. You might be using automation tools like Chef or Puppet to drive whole infrastructure within AWS and build infrastructure development. And deep security can sit as part of that. So that was a key development criteria for deep security. The other thing is that obviously applications are changing both in the way that they're built and in the rapidity with which they change. So with containers particularly, we're talking about microservers, so you don't have one monolithic application anymore, but you have lots of small processes that you sort of scale up as needs be, and then you can make lots of minor changes a day. So, I think Facebook would be a typical example of that kind of development environment where they're always changing stuff. You wouldn't know it, but you make small changes, you do small tests to small parts of code, and you can roll out little features all the time. So that's another thing that's changing. And then onto the security side of this, so obviously going to the cloud changes the way you work. You used to have a perimeter that you secured with firewalls and stuff, and then that kind of didn't exist anymore. And now we're going to the cloud, and you have these thousands of servers might come up in a day in an auto-scaling environment to maybe in response to a marketing plan or a competition. And so the idea of how to protect that with traditional perimeter-based security is quite tricky. So, we were thinking about that as well. And in terms of the threat sophistication, what we're seeing is that people have made a lot of money from ransomware. We've seen a lot more types of ransomware around. The typical approaches to defense, which were signature-based detection of malware, as now we've moved beyond that, where most malware's 0 day, a lot of it's 0 day in terms of signatures, if not attacks. I mean, still, people are looking for vulnerabilities to attack with, but we are seeing a lot more threats and a lot more complex threats, and the whole threat environment has increased dramatically. So, as a company, we needed to bear that in mind too. And then suddenly, your licensing and procurement becomes completely different as well. So you've gone to the cloud with some workloads, and Amazon give you a monthly bill, and they tell you it's so many cents an hour. So, traditional security was, I've got a server, and I need to buy a license for the security for that server for a year. And, we've changed now to a different model where you have to buy per hour. So Trend have looked at that too with deep security, and we've come up with innovative models there to match the billing environments that you find yourself in these days. So we do per hour billing as well. So deep security was built around these kind of challenging principles of modern compute environments. And what that really means in terms of threats is that there's a number of different, if you like, layers of defense you can apply. And I think it's a Gartner quote that says that there's no one single approach that's gonna win out, right? And the other thing that we always say is there's actually no silver bullets. There's no 100% guarantee that you're going to stop malware all the time. But if you look at these line of layers of defense, it's Trend's core technology principle that believes that you need all of these layers. And whilst you can get a lot of these layers from, you can buy these layers in many different vendors, it's Trend's goal, if you like, to provide as many of these layers as we can in a single product. So if we look at intrusion prevention, file integrity monitoring, log inspection, virtualized optimizing for a virtualized environment with agentless security, application control, sandbox analysis and machine learning, these are all things that we've put into deep security. With machine learning is due out very shortly, actually. It's not quite in there yet. But, the principle being that if you have all of these layers of technology in a product, then it's much easier to manage. There's some great technologies from other vendors, but it's an issue of taking on another, if you like, another bit of security software with another load of events to track and how effectively you can do that. So Trend really targeting, giving you all of these capabilities within a product. So what does that look like in reality? So in terms of what we do, Trend still believe in anti-malware signatures, in web reputation services, and lots of catching the known. So intrusion prevention services, which run at a deep packet inspection layer on your network interface, to detect attacks against known vulnerabilities. And obviously integrity monitoring, application control, so just locking down what's on your server and being made aware of any drift on that. And we'll see a demo of that later. But these are the things, these are the knowns and the unknowns. So those are the absolutely solid controls you can apply, right? But on the next layer, because the malware environment's changed hugely, and it's harder to detect the known malware. There's a lot more sort of stuff that's in the grey area that's not known whether it's good or bad, right? And we don't like false positives. So the next thing you do is you can apply some machine learning. Now, machine learning is a model of defense where you've taught some artificial intelligence techniques to look at your, if you know an unknown malware, and detect whether it's similar to known malwares that we have in a library. So Trend Micro run a smart protection network. That smart protection network is our global intelligence of malware. File reputation services, web reputation services, email reputation services. So we've got large databases of malware there. We've used those to train a machine learning engine that we now run in our endpoint technology that can look at files that are about to run and go, well, you're suspicious in that I don't have a registered digital cert for you on my goodware list in my smart protection network, and also you've got a low prevalence, i.e. I've not seen you before. So our smart protection network is a global thing. It has, we update it with 500,000 signatures a day, and we see billions of queries to it a day for reputation services. So we have a good idea of what's known and what isn't known. And these would be the things that we don't trust. And then you can, having knocked out the good and the bad with the simple low cost, if you like, methods, low intensive methods, you can apply more intensive methods to these and determine whether these look like some rewritten form of CryptoLocker, for instance. So someone's changed the signature on CryptoLocker, or they've messed around with the APIs, or they've changed some of the code slightly. We'll get that on pre-execution machine learning. Then we'll let it, if we can't identify it with 90% accuracy before it runs, then we will let it run. But as it runs, we'll do a couple of things. We'll do some behavioral analysis on it to make sure, or to understand the effect it's having on the system that it's running on. So if it looks like CryptoLocker, in that it's picking up a file, rapidly encrypting it, and then picking up another file and rapidly encrypting it and maybe giving it a certain signature or a certain file extension, then the behavioral analysis will come into play. And it came into play before, basically. Before it let the suspicious application run, it would take a snapshot of the file, saw that it was rapidly encrypted, and then lets that happen twice more, and then it'll stop that process and allow you to reverse out. So that's a typical behavioral analysis capability we have in deep security. We also have it in other endpoint products. We also can run there's also some runtime machine learning, which looks at the API calls being made and the system effects, so that we're looking really at what the code's doing as it runs, and we'll identify patterns in that to say, well, okay, we didn't identify you as CryptoLocker before, but now you're making these API calls, you're looking very much like it, and we'll stop you. So that's the advantage of machine learning and behavioral analysis. And in the final instance, we've got some sandboxing too, so some custom sandboxing analysis. So Trend can provide the capability for servers to deliver sample files to a custom sandbox. That custom sandbox runs your server image or your custom SOE image of your environment, so that if people are targeting malware particularly at you or your environment, we're going to pick that up because it's going to run as though it's running on one of your servers. And that's pretty important because we're seeing a lot more phishing attacks these days. Sandboxing is a great technology for finding the good from the bad. And once identified, we can create signatures or URLs or indicators of compromise, and then basically inoculate your environment against those. We can also communicate those indicators of compromise to third-party devices such as firewalls or edge protection. So this is core to understanding how Trend technology works, and this is part of our core tech principle, where we have a core technology group that we might go out and attain some technology or build our own technology, but it all becomes part of this core tech group and then gets distributed to all of our products. So deep security, Office Scan is our endpoint product, our deep discovery range of products, and they all get these, if you like, engine capabilities. So I talked briefly before about the Smart Protection Network. Here are some of the stats. We run that good file whitelist, so that's a great way of understanding what's good or bad. And we use that in endpoint application control, so you can use that as a way of determining or locking down whitelists of things people can run in the endpoint environment. We've got lots of sensors out there, honey pots and honey monkeys. I don't know if you know what a honey monkey is, but it acts like a user. It goes and clicks on all the stupid links and that kind of thing. And we analyze all that, and that gives us intelligence to learn about the malware. On the threat researcher side, Trend recently purchased Tipping Point, about a year and a half ago, 2 years ago. And with Tipping Point came the Zero-Day Threat Initiative Labs, run by DV Labs at Tipping Point. And that's 3,500 external researchers researching vulnerabilities. And what they do is they find vulnerabilities in OS, say Microsoft, for instance, and it's an interesting thing. If you go to the Microsoft site and look for acknowledgements, you'll find that Trend often are the biggest contributor by quite some margin on vulnerabilities found. Also, those researchers provide these vulnerabilities on a number of applications that you might run. So, web applications and applications that sit on top of the operating systems. So on the one hand, with the Tipping Point Labs and ZDI, we're finding out about the vulnerabilities. And that's really important because that allows us to write the IPS rules that we need to identify those vulnerabilities in a network attack. And then we can refute those, then we can reject those and reset the TCP connection on those vulnerabilities. So on the one side, I suppose, we're finding out about the attacks, and on the other side, we're finding out about the holes and defending against those attacks. So I talked a bit earlier about the challenges of Amazon and the typical network-based security. And network-based security is great, right? It's fine, but you need an in and out point when you come into your cloud. So say that's your VPC and you're running a UTM or a standard firewall. That has to scale up and scale down massively, and so you have to scale up and scale down those appliances, and that can be quite tricky. Or you have to reconfigure the network, that's all kind of awkward. That traditional perimeter model doesn't really work quite as well. Whereas in a typical trend model, we'd have security running on your workloads in agents. So we've got security running on each of those. So as those scale up and scale down, we'll find the malware on them. Not only that, but the east-west traffic thing is quite important. So if somebody compromises your host, say, on your on-prem infrastructure, they'll try and leverage that to get across any servers they can and infect your malware. So that's again why we would argue that the host-based approach for IPS, anti-malware, and those kinds of defenses on your servers is a great approach, because in a sense it's going to look at that east-west traffic as well. There are a number of ways of looking at east-west traffic. You can do deep discovery appliances that look at networking protocols and that kind of thing. But as your Amazon layers scale up and scale down, your security is built in. So that pretty much will bring me to the first automation point, which is that deep security provides easy-to-run scripts that you put in your build of your servers so that they are built and baked in with security, not only with the security agent running, but with the security agent downloading the correct policy, running the right policy for that type of server, and that happens as it's born. So say in a typical CI/CD type environment where you're using a Jenkins, maybe a Jenkins thing to create your code and deploy your code, you can create your instances built in with security as your developers create them, and that's the DevSecOps part of this. So what's in deep security in detail? So first of all, there's intrusion prevention. Intrusion prevention works this way on deep security. You run a recommendation scan. That recommendation scan comes up with a list of rules. And that recommendation scanners basically look for vulnerabilities in your host applications and your host operating system. You run that set of rules. That set of rules is customized to what's running on that server. You can have that automated, so it downloads and runs new rules should it find new things to defend against. And deep security can actually be set up to have a scheduled event task that allows you to run a recommendation scan and apply the rules automatically. So automating security with IPS rules, really important. You'll see shell shock and heartbleed icons up there. So those were two good examples of where we caught things. As soon as they were announced, people were trying to attack them. We had the IPS rules on hand to come down, and we protected hundreds of customers in the first few days on both of those. So really important, that automation bit. And IPS gives you this capability to kind of virtually patch, right? So staying up to date, and WannaCry is a great example here, staying up to date on your patching levels on your servers is hard. Everybody knows this. So Microsoft announced that it had the vulnerability and it released the patch, but a lot of people were still vulnerable because they hadn't patched. Were you running intrusion prevention, you could have downloaded the rule, or the rule would have come down, and it would have protected you against that WannaCry attack. So again, really important capability, and we've got a demo on that in a bit later. Some of the other layers I talked about, the standard sort of anti-malware and content stuff, behavioral analysis, looking for that ransomware type behavior, machine learning, both pre-execution, identifying before an application runs, whether it looks very much like some malware that we already know of. And then if we can't identify it with certainty, going to the runtime method where we're looking at its behavior in terms of the API calls and the opcodes it's running and going, oh yeah, actually you are some identified piece of malware. And in the final analysis, some sandbox analysis to submit files to allow you to fully detonate the threat. So that goes into a deep discovery analyzer box from Trend that basically creates your environment. It triggers the malware, and then it will fully detonate that malware. Even if it's got multiple phases and it's got dropper files and many different phases to it, we'll identify the full threat. We'll identify all the indicators of compromise around that threat and then communicate them back into your organization so that you can be inoculated from them. Another really important one, application control. So this is relatively recent in deep security, but basically this allows you to run a rule set or generate a rule set for your server. It looks at all application code that can run on the server, so that's whether it's script, whether it's executable. It looks at about 13 or 14 different file attributes to see whether they'd run. It builds a list of those and goes, right, here's all the code that can run on your server. Then what it can do is lock things down, or it can just advise as to whether any other code appears on that server that can run and is against that policy. So it gives you an idea of drift, and you can become aware of drift through an anti-malware event, and through that drift event you can either allow or block on a manual basis, or you can take some remediation action, such as, and I'll show you this later, you basically tell, deep security can tell Amazon Smart Notification Services. So the Smart Notification Services pick it up as an application control event. We can then run a Lambda script to identify that application control event and to take some remediation action. Integrity monitoring, so that's file integrity monitoring, is kind of all about understanding whether your files have changed in a suspicious way. So that might be, your host files changed or something like that, and would indicate those kind of things. So a lot of layers of technology there in deep security, really trying to identify the suspicious changes and defend against the attacks. So hybrid cloud generates a series of customer pain points. We talked about threat sophistication, we talked about speed of application changes, and the way the infrastructure is evolving. So what you need is a product that's well linked into a good threat protection capability and audit capabilities. Now, deep security logs into all your AWS environments. It can give you a full list of compute instances. It can tell you how they're protected or not. We can also allow you to create some organizational capability within that to understand what the servers are doing, what functions they're running, and whether you've got the right security posture for those servers. So that's more about the functional, if you like, the functional capability of the server. A web server would have a very different security posture to an application server or a database server. So it's important to understand and see those things in the context of what they are, and then be able to apply the appropriate security policy to them. You need the performance across a hybrid cloud, so you need to ensure that as your cloud scales from one instance to 1,000 instances in a day, how are you going to cope with that? I think there's that charity where you grow the moustache for charity. They have a unique kind of auto-scaling type environment. They do run an AWS cloud. The name escapes me of their... That's it. So obviously, Movember is their peak time. They need thousands of workloads during that time. They need to make sure their security performs during that time. They also only want to pay for licensing during that time. So really different kind of performance indicators and required. And that comes back to the point about automation, is that you want to ensure that not only security is built in at the point of build, so that's all automated and the policies are all automated, but should you get a security event, you possibly want to go back into AWS, run some Lambda scripts to deal with that security event, take some remedial action, and automate, if you like, the what would be a traditional manual security response. And the other thing is, we all don't have enough resources, right? So there's not enough cybersecurity resources in the world in general. There's lots of jobs going at the moment, and it's hard to hire cybersecurity professionals, and it's hard to understand and react to these events. So I'll just quickly whip through some of the capabilities. I talked briefly about smart folders. Smart folders allow you to identify your workloads by perhaps AWS tag or the name of the server or the function of the server. That smart folder then contains those servers, and I'll show you that later on. But then that gives you visibility around certain functions for certain folders. So you might want all your Docker servers in one smart folder, so they're running a certain kind of security posture. So this is how you create the smart folder in deep security. As you can see, there are a number of computer properties you run there. In fact, there's a clever bit of code that can auto-create your smart folders based on your AWS tag names. So you could, by your AWS tagging policy and capability, you can automate the smart folders these go into, and that gives you an organized view of your thousands of workloads. I don't know, one thing I find in AWS is that certainly the number of workloads grows hugely, and understanding and organizing that from a security point of view is really important, and visibility is key to that. Really important point is that we integrate deep security back into the simple notification services. So we can pass on all the malware events, firewall events, intrusion prevention events, and those events can then be used, obviously, by Amazon in certain ways and be published to Amazon notification services. This is the application control. So this is where we scan the server. We build effectively a whitelist of all the applications that run, and you can allow or block. You can sort of allow and be aware that it's drift, or you can just block it from running entirely. And the administration control panel looks like this. So there's a kind of actions board. You can see the 47 occurrences of unrecognized software there, so you get an idea of the drift. And then you can share rule sets as well. So you can build a rule set from a computer, and then you can share it with others so that you can ensure that perhaps your pre-prod environment looks exactly like your prod environment in terms of its executable code. And that's, I think that's a useful thing in terms of rapidly evolving environments where lots of changes happening at the same time. So the key thing about this is that you can build it into your pipeline. So security and development used to be over here, right? Development wants to go, I want to just make this change. And security go, well, you have to go through this process. What we've done is we built deep security to work with both arms together, if you like. So you use your deployment tool, Jenkins or Ansible or Chef or whatever, and it can call a deep security API at the point of post-build, but at the point of deploying, and take the workload into a maintenance mode where you deploy the new executable code, and then you lock the server down again. So you've got this secure deployment process that you can build into your DevSecOps processes, so that no longer are development and security kind of at each other's throats about not breaking the rules, but you've built it into the tools that everybody's got. And finally, the capability to understand and sandbox out files. So here you see a typical detect, analyze, respond, prevent virtuous circle of security, where suspicious files are handed by deep security into an analyzer. They're sandboxed out, identified in terms of their suspicious object list or a suspicious objects list, a signature or a URL or a domain, and then we can respond and then basically prevent. So we can lock down, we can provide those indicators of compromise across your environment and ensure that the whole environment is inoculated. So typically a good control to run. And this was the behavior monitoring that I talked about earlier. So typically in a ransomware situation where ransomware is trying to run on the host, you can identify some behavior here, and you can detect the suspicious activity, such as unauthorized changes, and it will back up and restore your ransomware encrypted files. So that's basically, allowing you to roll back from a ransomware encryption or a ransomware attack, and it stops the process, quarantines the application file, and then restores your unencrypted files back. So it can really save the day in terms of a ransomware attack. And finally, and I think the other thing to mention is Docker. So a lot of you may be coming across Docker now. The idea of containers isn't a new one, but it certainly seems to be the flavor of the month now. So we've got some Docker capabilities to look at IPS and real-time anti-malware within a Docker environment. So I'm just going to run you through a demo here of basically a suspicious file ending up on a cloud instance. So this is a demo system called Bryce Systems, and you can see that it's a scalable Docker-type environment. And we're going to basically, it's running a website where we're protecting the Bryce systems. Here they are. They're all Docker AMI images, and these are running a website where you can submit your CV. So we've got it protected by deep security, and we're about to apply for the job. Now, instead of putting up a CV, we're going to put up a malicious file. And we're going to find some docx, which is a Word file, but it's got a macro in it, and we're going to apply with that. So we just submitted it onto that server. So it's ended up basically on your server, protected by deep security. Now, you can send it in, and faintly in the background there's an error there, but where it basically quarantined the file immediately. So in the dashboard here, we can go to the quarantine event, and we're going to go to ransomware status here, and we have a look at the event. And you can see that this event occurred against this computer. We found an infected file, and we quarantined that infected file. So all well and good, nothing new there, right? That's standard security for a suspicious object. The difference here is that when we reported that event also got reported via the simple notification service to Amazon. And we ran a Lambda script looking for this error, and we basically had some Lambda code to back up that instance of that workload and create a new one. So we terminated the Cloud ECS instance there and brought up a new one. We backed it up so you can run an investigation on it as you normally would, but we've automated the response here. So typically if ransomware arrived on a server or an endpoint in today's environment, you'd have to isolate it from the network, take it away, replace it with something, build a new server obviously, and then do your investigation all manually. So we've sort of automated part of that process for you. So there you go. What happened? Attacker uploaded a bad file. You had a detect and report to Deep Security Manager. It gave the trigger via simple notification service to Lambda. Lambda said, right, take that host, well, basically add another host, create a snapshot of that host, and terminate it. And that sits in an auto-scaling group. So this is a nice way of automating a security incident response. The next one is kind of an IPS capability. So what we have here is a WordPress site. I think it's WordPress 5.3. And WordPress, we've got two WordPress sites actually, one that's protected and one that isn't. And these sites would be open to a WordPress attack. So what we'll see here is a WordPress attack that's going to hack your website. So here are the websites in EC2, and here they're protected in deep security. So we'll just have a look at the security things that are turned on. We've got intrusion prevention turned on, and in intrusion prevention, this is in prevent, right? So we've got prevent capability, and we ran a recommendation scan on it, and it found WordPress as an application on the server, and it got the right WordPress rules for that version of WordPress. On the other, I was just showing you on the other server, there is no security at all. Right, so here we go. We're going to do the attack now. So we're just going to download the attack code from GitHub. It's up there currently. You can just get it and run it. And we're just going to run it as a Python script. There we go. We've run it against the. We're just going to run it against the Bryce URL there. Oh yeah, WordPress 4.7. It's vulnerable. Let's overwrite some of the content that it's going. So you choose the content you want to overwrite. 5 reasons you need your cell phone insurance, and you change that to you've been hacked. And we've changed some other content there. So you click load to continue, and then you refresh your website. Next thing you know, you've been hacked. Whatever. So this is a current WordPress. Well, it was current. I don't know if they've updated now. And you could do that against a WordPress site with that GitHub code. Right. So this is with the server that's protected with IPS. So we're going to do exactly the same thing, but Bryce Industries A is protected with an IPS rule where the rules have been set and turned on. We run the recommendation scan. It's detected WordPress. It's put the right rules in place to protect us from the known vulnerabilities there. Here we go. We're going to do the attack. It's going, yeah, you're still vulnerable because it still sees the vulnerability, right? It detects the version. And the hacker thinks, great, fantastic, another vulnerable one. I'll change it, and we'll ask for a ransom or something. And you can see there are a bunch of errors and a gateway timeout. And that's because the IPS rules on the server detected what was going on. So, all well and good. In terms of the deep security side of this and what's gone on, we can show you the capability here. So, in deep security, you can look at the intrusion prevention event, and it will tell you about it, and it will tell you how it blocked it. So we've got it in prevent mode, and 21 rules are turned on. And in the code itself, it'll show you where it picked it up and what it picked up. So you've got the actual event there picked up. And, this could be any vulnerability, and I'm going to show you a WannaCry one in a minute, which is a much more relevant one, I guess, for some people. And that was about the IPS rule for WannaCry. So there's the actual event there. Cool. And you've been hacked. So deep security turned on there, and look at doing deep packet inspection on the network interface and running the IPS rule appropriate to the application found on the event there. On the Lambda side of this, we looked for the instance being affected there, and we created a snapshot of the database and had a new server come up. So again, we're trying to save the content, and then you just bring a new web server up. So you've seen the attack, you've made sure you've taken some remediation action, and that your database has been saved. So there we go. That's it in detail. So we run the exploit. That was on a EC2 instance. It reported to Deep Security Manager. Again, simple notification server got it through. Lambda function picked it up, and we took the snapshot and rebuilt the server, had the server autoscale. So if you want to switch to me now, we can do some. Oh, you're going to watch me log in now. There we go. Right. So, in this demo, I'm going to show you the application control capability. So this is showing some servers that are locked down with application control, and the scenario is that something's gone wrong on the dev server, right? On the production server, and the developer needs to go and fix it. And he's really keen to get his hands dirty and going to fix it. So he's going to go and try and mess around with executable file on a EC2 instance, and we're going to have a response to that. So I'll talk through that. Right. So on the So here's my EC2 console. Here's my application server here. So the first thing the developer, he finds some code's not working. He goes, right, well, I'm going to get onto that application server. And the first thing he's going to do is give himself permission to get into the server. So he's going to change the security groups and allow himself in on SSH. So that has effectively changed the security groups here. And if we have a look at that security group on the inbound rules, we can now get in on SSH on his IP address. He'd normally have to actually set up a rule, but I've done it in advance. Now, here's the guy. He's going to go in via SSH and open up a session. And he's going to get onto the server, and he's going to log in to the server and make a change. So we're just authenticating the server, and if the demo gods are with me, they are. We're in. So he's going to create some executable code on the server. So we'll just get into here, and we'll create some code. There we go. So that's cool. We're going to do hello world. And we'll just quit out of that. So there, we've got a script to run. And we go, great, okay, so I'm going to run my script and fix up this code. And so let's first of all try running mic.sh. Didn't let me run. Oh, but I'm a developer, I'm God, why can't I run this? I know, sudo. So we'll go sudo's root, and then we'll run mic.sh. I still can't run. Hold on. Something's popped up in my Slack environment. So Slack being the developers' tool of choice these days to communicate with each other, we've linked Slack into deep security. So deep security is talking to SNS. Lambda's picking that up, and then Lambda's talking back to Slack. And there's the Slack event saying, oh, look, Mick didn't run. So 11:46 a.m., and it's an application control. And he goes, there's application control going on here. So on the deep security side there, what we saw was, excuse me a minute, I'm just have to log back in. So on the deep security side of that, we saw an application control event. That application control event was reported into the SNS that went to Amazon. Amazon took it out, reported it back into the Slack events there in the developer channel, so he knows what's going on. And if we look at actions here, you can see that the deep security saw the drift. So here's my occurrences of drift here, and if I look at the latest ones, there's the MIC SH one. So application control is a nice control for allowing unauthorized changes, but obviously we've seen here that we can communicate it back to the developers. And on the EC2 side of this, we took some action too, actually. So the Lambda script that looked for this capability, actually, you can see here, it was looking for execution of unrecognized software blocked. It's looking for that event. And what it's done is reset the security groups back on that application server. So if I have a look at the application server, it didn't take the application server down at all, but if we have a look at that EC2 instance again, we've automatically remediated that back to its normal security groups. If you remember, I had the SSH one there before. And I can kind of prove that to you by running the putty script again. So let's run putty again and try and get into my server. Just load that up and open again. Here we go. I'm trying exactly the same things I did before, and it's reset the security groups, and it's not going to let me in. So again, a nice way of deep security talking back into Amazon and allowing us to basically have an automated response to a capability. Now, this is just an example. I guess, there are many ways of thinking about this, but if your server's doing something out of the ordinary, and it might be, if it made a command and control call, for instance, you might want to know about that, because perhaps the server shouldn't be making any web calls at all, so you might want to know about that. And if it was, then you go, okay, if it's making a call to a command and control server, let's lock it out and make it stop. So the other demo that I had for you today is a WannaCry-based one. So what I've set up here, just to go back to EC2, I've set this all up in Amazon. And if you're interested in security and would like to do this yourself, we have some instructions that will take you all the way through setting up this demo and running it. But basically, it's a demo around WannaCry. And you'll see I've got two Windows 2008 servers. Unfortunately, I haven't been able to patch them in time. And one's got an IDS policy running on it, i.e. it's going to detect, and the other's got an IPS policy, it's going to prevent. And I've got a Metasploit server here to run the Eternal Blue exploit against these machines. All right, so let's look at my Armitage is if you like, the GUI for Metasploit. And it makes hacking easy, point-and-click kind of stuff. So I've actually already run a scan on this. So you select basically you identify the hosts that you can get to. And in reality, what was happening with WannaCry was that WannaCry would infect one machine and basically do an automated process of this to a load of other machines. It'd go, what can I see? And are they vulnerable on SMB v1 to Eternal Blue? And it would do this kind of quick scan. So I'm going to select my other server here. So they're both Windows 2008 servers. And we'll just do an nmap scan, and we'll detect the OS, and we'll just do a quick scan there. Click OK. Off it goes and does the scan. So one of the things is that it'll show you the results of the scan. So that was the result of my scan before. This will be the result of this scan. So we'll just wait for that to pop up. Meanwhile, I'm going to go back to this one, and I'm going to find attacks that are available to me on that server, given what it is, right? So I've done an Nmap scan, I've found out it's Windows, and now I'm going through my database of known attacks to find out what I can do. So it goes, yeah, we found loads of attacks there. You go, oh, great, okay. So let's just search for Eternal Blue. Oh, I've been driven out of the dialog box. So we're going to search for Eternal Blue here. And there it is. Okay, MS17 underscore 010. And I'm just going to tune my attack to not bother to verify the target. Just go for it. And I'm going to launch that attack. So again, in Metasploit, you get another little thing going here. So we've launched the attack, and we'll just wait for it to come back, and hopefully we'll see it crack into this machine. Now the one on the right, to just go back to deep security here, I can just show you the two application servers and their protection. So here's my deep security dashboard view, and in the computer section here, well, they both detected a reconnaissance scan, and that's absolutely right, because that's just what I've done. But if I click on the second one here, and we look at intrusion prevention, we run a recommendation scan, and it came up with 617 rules. It's on and in prevent mode, okay? So we've got that running there. On the other one, we still have intrusion prevention on, but it's just in detect. Right. So let's go back to, we'll see how that's getting on. Let's have a look. So we'll just try that exploit again. Live demos, huh? It's one of those things. So we'll just try that attack again. On the other one, we'll try the attack. There we go, we've cracked it, right? So that's now cracked. And I can run a bunch of stuff on this. I can shell into it. And here's my Windows login, right? So that's an Eternal Blue WannaCry type attack against a vulnerable machine. And on this side, we're going to run this attack as well. So it would have set up my remote host automatically. So that's going to 158. That's good. Let's just not verify the target. And we're going to launch that attack. So that attack will launch, and it's going to fail, basically. And let's go back to deep security and see this happening in real life. So let's go and have a look at that second server. Intrusion prevention. Takes a while for the system events to come through. So we'll just have a quick look. And we should see it defend against a WordPress attack here when it updates. So that's, I suppose, the benefit of what this is showing is really that IPS, the auto download of an IPS rule on the day that Microsoft announced the flaw and the fix, right? So what happens is that, they're told about the vulnerability, they go and fix the vulnerability, and they go, here's the vulnerability, here's the fix, download this patch, download it now. Obviously you can't do that, but your intrusion prevention rules can. Okay, I may have a networking issue, I don't know what I've got now. But anyway, those were the two live demos I wanted to show you, and we had some recorded demos there. I think I wanted to leave you with some final things that might be useful. This is a slide that came out about workload security and AWS growth. So we did 1 billion protection hours in just the last 8 months, as the first billion took the first 26. So you can see that really growing there. There was something else I wanted to show you that is a great site that we're running now. It's called Phishing Site. It allows you to run your own phishing campaigns in your own organizations. You can set up a campaign, you can create a campaign, you can test your own people. It's also got a news section, and it's got some free tools. Finally, if we just go back to the final slide. So really what I was trying to show the automated threat response and how you can get your, if you like, your security to talk to your DevOps environment, to talk to your AWS environment, and to do some intelligent stuff off the back of that. And I was also trying to get across the fact that we don't just believe in one layer of technology. You've got to have multiple layers. Machine learning, behavior monitoring, sandboxing. They're all great things to have because the threat environment is much more complex today. So I think back to the clicker. Gartner. All right, so it's out there. So we're still doing quite well. I suppose we're due another one shortly, January 2018. But I think what they're saying is that trend think about a lot of stuff. So and some other rah-rah stuff about what we do. I suppose the breach detection stuff's quite interesting in light of GDPR and the requirement to report breaches now within 30 days that's going to come live next year. So understanding that it would be a key one. Obviously, in the server security market here in IDC, we've been a market leader for a while. Okay, thank you very much.